Guys, welcome to our channel. So today we are going to continue with our massive A-level revision. So today we are having this question paper, and this is June 2024 session, physics paper 3 for advanced level, and this is Zimsec examination board. And if you are doing other examination boards, just pay attention to the data, and physics just physics. Okay, so in this question paper we are going to answer all questions, but today we are going to focus more on question number 1, which is of classic mechanics. Okay, so we have this data here: the speed of light in free space, which is 3 times 10 to the power 8 meters per second, the permeability of free space, the permittivity of free space, the elementary charge, the Planck constant, the unified atomic mass of 1.6 times 10 to the power negative 27 kg, the rest mass of electron, and so forth. So just know that this information will be of essential importance when you're answering some questions, just like this one. This is the most important information. This constant here, the g, the acceleration due to gravity. So whenever you are required to use the g, just to use 9.81. And there's also this constant, another constant, the Boltzmann constant, the k, and we usually use this constant in topic of matter. So Boltzmann constant, it is 1.38 times 10 to the power negative 23, and there's also gravitational constant for gravitation, 6.67 times 10 to the power negative 11, and there's also the rest mass of electron. This one, it is also important to know this. It is 9.11 times 10 to the power negative 31. Okay, and let us move on to another group of data. There is these formulas: the uniformly accelerated motion, these solved equations. We have S is equal to ut plus half at squared, and V squared is equal to u squared plus 2s. And these two equations, you should know how to derive these two equations from this one. V is equal to u plus at, and the other one is S is equal to half V plus t, V plus u multiplied by t. Okay, and there's also the formula of work done by gas. This is pressure multiplied by the change in volume. There's gravitational potential in gravitation, and there's also pressure of ideal gas, the ideal gas. There's simple harmonic motion, there's velocity in simple harmonic motion. V is equal to v naught cos omega t. There's this one here, and you should also know how to derive this equation. Okay, and there's also attenuation of X-rays. This is intensity, this is the initial intensity, this is attenuation coefficient, and this is thickness. And there's also electric potential, capacitors, and series. So all this information is of essential importance whenever you are answering a physics question paper. Okay, so let us dive into our first question number 1. So number 1, it is compulsory, but if you're not doing Zimsec, it doesn't matter for you to understand these instructions. So let us dive into our question paper. So number 1 is saying state the Archimedes principle. So we are going to state the Archimedes principle. So as the Archimedes principle states that for a given that you're having a fully immersed board or a partial immersed board, the upthrust, it is equal to the weight of the volume of the liquid displaced. Okay, so we can say Archimedes principle says that for a partly or fully immersed board, so or a fully immersed board, upthrust it is upthrust is equal to the weight of the fluid displaced. So this is our Archimedes principle. But for us to have a better understanding of what the Archimedes principle is, we should also appreciate this word here, upthrust. So what is upthrust? So upthrust, let's say we are having a beaker like this, and there's water here, and we immerse something like this, and there is h, the height from this point to this point. Okay, and we understand from our equation of pressure that pressure, it is equal to rho gh. Therefore pressure increases with depth, meaning to say pressure at this point, it is less than pressure at this point. So pressure, it is equal to force per unit area, and if we are to calculate force, we can now say force, it is equal to pressure times area. Therefore, if pressure at this point, it is very high as compared to pressure at this point, this simply means that force at this point, it is higher than force at this point. So there will be a resultant upward force. Why? A resultant upward force, because force at this point is greater than force at this point. So if these two forces, they're not equal, there will be upward force. And this upward force, this is what we call the upthrust. So upthrust, it is an upward force where there's a difference in force between the upper surface and the lower surface in a fluid. Okay, so there are two types of fluids. I think you are all aware that gas is another form of fluid. So liquid is a fluid and gas, it is also a fluid. Okay. And let us move on to number 2, the part 2 of our question. So the second part of our question is saying an iron block of mass 0.6 kg is hung from the end of a thread and totally immersed in water. So we are having an iron block of mass 0.6 kg hung from the end of the thread and totally immersed in water. And the density of the iron is 8 times 10 to the power 3 kg per cubic meter, and the density of water, it is 10 to the power 3 kg per cubic meter. So this is the density of the iron, and this is the density of water. So the first part of the question, we are required to sketch the free body diagram showing all the forces of the acting on the system. So the system is like this, and you are having this water, and there is also this thread here, and we are told that the iron block is totally immersed in water. So this is total immersion of this iron block, and there is tension acting in this direction. So this is our tension, and there is also weight of the block, and there is upthrust acting in this direction. So whenever you have drawn your free body diagram, just include the key to say T is for what? T is for tension, and then W, it is for weight, and then also U is for upthrust. So there are two forces acting upwards, tension and upthrust, and there's only one force that is acting downwards, that is the weight. So this is our free body diagram. Here is our free body diagram showing tension, upthrust and weight. And then in the second part of the question, we are required to calculate the tension in the thread. So we are required to calculate the tension in the thread. Okay, so given that this system, it is in equilibrium, so when the system is in equilibrium, the forces that are acting upwards must be equal to the forces that are acting downwards. Okay, so given that we are only having one force that is acting downwards, that is our weight. So weight will be equal to tension plus upthrust. But in this case, we are going to calculate tension. Therefore, tension, it is equal to weight minus upthrust. Okay, so what we need to calculate here, it is our upthrust, because weight is very easy. Weight, it is the effect of gravitational force on mass. Therefore, weight, it is equal to mg, and we have our mass of 0.6 kg, and also we have our acceleration due to gravity 9.81. So this is the mass of the iron, and this is the acceleration due to gravity. Okay, so what we need to do is to calculate upthrust. So upthrust, according to Archimedes principle, it is equal to the weight of the fluid displaced. So the weight of the fluid displaced, it is rho g v. So this is the volume. This is the volume, and this is the acceleration due to gravity or gravitational field strength, and this is the density. So from our definition of density, we understand that density, it is equal to mass over volume. So density is equal to mass over volume, and if we are to calculate mass, we can now say mass, it is equal to density by volume. So mass is equal to density by volume. So weight, it is equal to mg, that is our weight. Therefore, if mass of the fluid, it is the density of the fluid multiplied by the volume of the fluid, then say with the weight of the fluid here, it is rho gv, where rho multiplied by v is the mass and g, it is the acceleration due to gravity. That is where we have derived this equation rho gv for the from the weight of the fluid. Okay, so let us rub this. So we want to calculate the upthrust. Okay, so upthrust, the weight of the fluid, it is rho. The density, this density is the density of the fluid multiplied by the volume. This volume, it is the volume of the displaced fluid, and there's also acceleration due to gravity 9.81. So the density of the fluid, it is here 1 times 10 to the power 3 kg per cubic meter. And what about the volume of the displaced fluid? So given that we are having this beaker here, and this it is 20. Let's say this is 20 cubic centimeters, and then if we immerse a stone, the volume of water rises to something like 30 cubic centimeters after we have immersed this stone here. So for us to calculate the volume of the stone, we can now say it is 30 minus 20, which is equal to 10 cubic centimeters. So this is the same way we can calculate the volume of the displaced fluid. So the volume of the displaced fluid, it is equal to the volume of the iron block. Okay, so given that the iron block, the density of the iron block, the density of iron block, it is equal to 8 times 10 to the power 3. For us to calculate the volume, given that we have this equation, density is equal to mass over volume. So for us to calculate the volume of the iron block, we can simply make volume the subject. Therefore volume is equal to mass over what? Mass over density. Okay, so the density of the iron block, it is 8 times 10 to the power 3, and also the mass of the iron block, it is 0.6. so volume of the iron block, it is 0.6 for mass divided by 8 times 10 to the power 3 for 8 times 10 to the power 3 for density. Okay, so let us divide 0.6 by 8 times 10 to the power 3, and this gives us 0. Let me write it like this. This gives us 7.5 times 10 to the power negative 5 cubic meters. So this is the volume of the iron block. So the volume of the iron block, it is 7 times 5 times 10 to the power negative 5 cubic meters. Okay, and we are then required to calculate the upthrust, and our upthrust it is equal to the weight of the fluid displaced. So the weight of the fluid displaced, it is equal to the density of the fluid, that is 10 to the power 3 times the volume of the fluid displaced, that is 7 times 5 times 5 times 10 to the power negative 5 times 9.81. Okay, so if we multiply 10 to the power 3 by 7.5 times 10 to the power negative 5 by 9.81, our answer will be 0.74 newtons. So the weight of the fluid displaced, or the upthrust, it is equal to 0.74 newtons. And in this case, we're required to calculate the tension. So weight of the iron block, it is 0.6, the mass times 9.81, the gravitational field strength. So it is now 0.6 times 9.81. So this gives us 5.886 newtons. Okay, so this is our weight of the block. Therefore tension, it is equal to 5.89 minus 0.74. so let us subtract 0.74 from 5.89. so it's 5.89 minus 0.74. so this gives us tension being equal to 5.1 or 5.2 newtons. So our answer, it is approximately 5.2 newtons. So this is the tension in the thread. Okay, and let us move on to the next part of our question, which says state the principle of conservation of energy. So the principle of conservation of energy states that energy is neither created nor destroyed, but it is transformed from one form to another. So I need you to comment on our comment section what is meant by the term closed system. From our principle of conservation of energy, stated that the total energy of a closed system is constant. So just answer what is meant by the term closed system. What is a closed system in our comment section? Okay, so let us move on to the second part of our question, and this is item 2, which is saying figure 1.1 shows a car of mass 1.3 times 10 to the power 3 kg, which has moved 500 meters up a road inclined at an angle theta to the horizontal, and we are told that sin theta is equal to 1/25. So we are required to calculate the change in gravitational potential energy. So the change in gravitational potential energy, it is equal to mg multiplied by the change in height, because what is changing here, it is height from this point to this point. Okay, so the first thing we need to do, it is to calculate the change in height, because we are having a right angle here, and this is our hypotenuse, and this is our adjacent, and we are also having opposite. Okay, so for us to calculate opposite, you can use this these trig ratios, it's Chashaw, and tau. So this is for cosine, and this is hypotenuse and adjacent. So when we're having a cosine, it is cosine theta and adjacent over hypotenuse, okay? And this is for sine, and if we're having sine, it is now sine theta being equal to opposite over adjacent, okay? So in this case we want opposite and we have this adjacent, okay? So we can now say opposite, or the change in height, it is equal to the change in height, it is equal to sine theta multiplied by hypotenuse, okay? So our sine theta, it is equal to 1 over 25, and our hypotenuse, it is equal to 500. So the change in height, it is 500 times 1 over 25. So the change in height, it is equal to 20 meters. That is our change in height. And we are also required to calculate the change in gravitational potential energy, given that you're having this mass and the change in height, and also the acceleration due to gravity, or the gravitational field strength. So the change in gravitational potential energy, EP, it is equal to the mass of the car, 1.3 times 10 to the power 3 kg, times 9.81, the gravitational field strength, multiplied by 20 meters, okay? So this gives us 1.3 times 10 to the power 3 multiplied by 9.81 multiplied by 20, okay? So our final answer for the change in gravitational potential energy, it is 2.55 times 10 to the power 5 joules. So here is our change in gravitational potential energy, okay? And let us move on to the next part of our question, which says explain the term efficiency of the machine. So efficiency of the machine, it's either, we can say efficiency of the machine, it's either energy out over energy input, or it is power output over power input. So that is our efficiency, and usually our efficiency is calculated in percentage, okay? And the next part of our question requires us to explain why the efficiency of the car is less than 100%. So the efficiency of every machine, it is always less than 100%. Why? Because there are other forms of energy. Like this car, it is moving from this point to this point, and this road is rough. So this mechanical energy, or the kinetic energy of this moving car, it is not only being converted into gravitational potential energy at this point, but it is also being converted into heat energy due to frictional force on this surface, okay? So due to frictional force, the kinetic energy, it is not all being converted into gravitational potential energy. That's why the efficiency of the car, it is less than 100%. But if the efficiency of the car was to be 100%, the kinetic energy of the car must be equal to the gravitational potential of the car at this point, meaning to say all of the kinetic energy of this car will be converted into the gravitational potential energy, okay? And let us move on to the next part of our question. This is part C, and we are still on number 1. So the question says figure 1.2 shows a small bead threaded on a smooth circular wire of radius 50 centimeters, which is fixed in a vertical plane. The bead is projected from the lowest point of the wire with the speed of v is equal to square root of 5g r, okay? So v at this point, it is equal to square root of 5g r, and we are required to find the speed of the bead when it is turned through 60 degrees, okay? So one thing to note, this is not circular motion, but the principle we are going to use here, it is the principle of conservation of energy, to say energy is neither created nor destroyed, but it is transformed from one form to another, or the total energy of the closed system, it is constant, okay? So at this point here, this bit, it is only kinetic energy and zero gravitational potential energy. So kinetic energy at this point, it is maximum. So here we have maximum kinetic energy, therefore the kinetic energy will decrease as it go around this circular path, okay? So the kinetic energy, or the energy at this point, the energy, you can say the total energy, it is equal to and we can label this point here, we can label it point A. So at this point, it is point A. So the total kinetic energy, or the total energy at this point, it is equal to the kinetic energy at point A plus the kinetic energy at point A plus the gravitational potential energy at point A. So we are going to calculate the speed of the bead when it is turned through 60 degrees. So speed, we are interested with this term here, the kinetic energy at point A. Therefore, kinetic energy at point A, it is equal to total energy minus gravitational potential energy at point A. So let us try to calculate the gravitational potential energy at point A. So we can draw a horizontal line like this, and we will form a right angled triangle. So this will be L, the length of the wire of the thread, and this is our hypotenuse. And then from this point to this point, it is our adjacent, and from this point to this point, it is opposite. And we're also told that from this point to this point, it is equal to L again. From this point at the center to this lowest point, it is L. So for us to calculate the gravitational potential energy at point A, we understand that gravitational potential energy, it is equal to mg multiplied by the change in height. So we need to calculate the change in height, which is equal to the height from this point minus the height from this point, from the center to the center. So we are interested with this height here, like this. This is our change in height. Okay, so we can now say this we can label this x. So x, it is from this point to this point. So x, it is equal to L cosine 60. And what is our L? Our L, it is 0.5. So x, it is equal to 0.5 cosine 60. And what is cosine 60? It is half. Okay, so it is now 0.5 multiplied by 0.5, and this gives us 0.25. So x is equal to 0.25 meters. Okay, so from this point to this point, it is equal to 0.25 meters. Okay, so given that from this point to this point is 0.25, therefore if from this center to this point, the lowest point is 0.5, this simply means that the change in height, it is also 0.25 meters. So we can simply calculate the change in gravitational potential energy at point A. So it is now change in gravitational potential energy at point A, it is mg, the change in height, and our m, the mass of the bead. So we don't have the mass of the bead, so we can simply write m, and g multiplied by the change in height. So our change in height, it is 0.25. Okay, so the gravitational potential energy at point A, it is equal to 0.25 mg. So okay, take note of this one, and let us move on to the next stage of our calculation, to say the total kinetic energy at this point. The total kinetic energy at this point, given that the speed at this point, it is square root of 5gr, and we all know that kinetic energy, it is equal to half mv squared. So kinetic energy, it is equal to half m, and our v, it is the square root of 5gr squared. So if we're having a square root and then square the square root, we can simply remove the square root to say our kinetic energy, it is now equal to 5/2 mgr, like this. So this is our kinetic energy at this point. So this is our total energy, 5/2 multiplied by mgr, because we have removed this square root sign. And we can now say the total energy, we can now say the kinetic energy at point A, it is equal to the total energy or the kinetic energy at this point, which is 5/2 mgr minus 0.25 mg. Okay, and for this kinetic energy at point A, we can now substitute with the formula of kinetic energy, because we want the speed at this point. So it is now half mv squared being equal to what? So let me use another color for this one. Okay, so it's half mv squared, and the v, it is the speed at A, being equal to 5/2 mgr minus 0.25 mg. So we can factor out m on the left hand side of the equation. Therefore it is now half mv squared being equal to mg. So we can factor out mg because mg is a common factor here. So it is now mg, a factor of 5/2 r minus 0.25, like this. So we can cancel these m's. So we are now left with half of v squared, half of v squared being equal to g, 5/2 r minus 0.25, like this. So we can now say it's half of va squared being equal to our g, and 5/2, it's 5/2 multiplied by r, which is 0.5, and this gives us 1.25 minus 0.25, like this. Therefore, half VA squared, it is equal to G multiplied by 1.00, because you've subtracted 0.25 from 1.25. Therefore, half VA squared, it is equal to 9.81, the value of G. Therefore, V squared, it is equal to 9.81 times 2. So 9.81 times 2, this gives us 19.62. So VA squared, it is equal to 19.62. And let us calculate the square root of 19.62, and this gives us what? It gives us 4.4. So our answer will be 4.4 meters per second. So this is our final answer for this question. Okay.